So welcome to everybody to this webinar of FoodWaStop cost action. It is the first webinar, but I'm confident that this is the first of a long list. And congratulations to Vugi4, that is the most numerous working group. You are working very well, and Jessica is doing a very good job. So it is great to have this start of a webinar with talking about AI. That is a pretty fancy subject, and it is a pleasure to have two speakers, so Enrique Barallón Catalán and Francisco Javier Alvarez Martinez, that will instruct us on this new frontier. And so the action is progressing well, is getting a lot of attention, and we are all of us proud. And I thank you for all the great work that you are doing. And today we had the news, a good news. Some people joined action, apply for a lot of people that already applied, and maybe some of them will, because it looks that. Okay, so you are welcome to benefit of all the actions that the cost FoodWaStop can takes, and all the funding that are available. From tomorrow, we will be in Thessaloniki for a training school, and several of the people that are here will be there as trainer or trainee. So that's it, and thanks for your interest. And I leave the floor to Jessica Girardi, that is the Vugi4 leader.
Thank you, Gianfranco, for the introduction, and thank you everyone to be here. I'm very happy that as a Vugi4, we are starting this series of webinar within our cost action. I'm just welcoming everyone, and I'm very grateful for Enrique and Janvier that they proposed the topic and they prepare the today presentation. And I am myself very willing to learn about this tool, because I believe it will be very useful, not just within our work in the cost action, but in general, in our work as a researcher. And so thank you very much for that. I will not take other time and leave immediately the floor to Enrique and Janvier, so please feel free to jump in.
Okay, so thank you so much for the kind presentations. I am Javier, and I'm going to share my screen so you can see the presentation. Okay, so can you see the screen?
Yes. Yeah. Perfect, Javi.
Perfect. So thank you so much for letting us the opportunity to talk about this AI tool that we are using at our laboratory, our group, for a couple of years now, since it was created by the team. So we are very happy to share it with you. We have been perfectioning and optimizing this tool that is called AI Reviewer. And alongside this session, that is going to last for an hour and a half, more or less, me, Francisco Javier, and Dr. Enrique Barrajón will guide you through the tool that is applied to the massive analysis of scientific information, and we will provide some specific examples, and also will make a bit of an interactive activity and questions. So before we really begin, I want to tell you that you can stop me at any time to ask questions. But in any case, if you have we will have some specific session in the near future just to answer your questions that you will put into a survey at the end of the session. And you can ask questions in English or in Spanish in the case it's your preferred language. But if you ask in Spanish, we will translate it to English in order to follow for everyone. So first, the team behind this AI tool is composed of 4 people. First is Dr. Fernando Borras Rocher. Second is Dr. Vicente Micol Molina. Third is Enrique Barrajón Catalán, that is here with us today. And lastly, it's me, Francisco Javier Álvarez Martínez. So why we created this tool? And it's because we identified a problem. And that problem was that according to How to Read the Paper, that's a guide recommended by Stanford University, it takes you between 1 and 5 hours to really read and understand the average scientific article. So when you are trying to do a scientific review, it involves a lot of time that it includes searching, selecting, and reading tens or hundreds of articles. And also the selection process of the most relevant articles, it's subject to some biases due to your expertise, your research experience, time limitations, and other type of constraints or personal affinity towards certain topics. So it's not the most objective process in the world. So in order to facilitate and speed up this process and also provide more objectivity, we prepared a reviewer. That is this tool that helps us overcome all these problems. First, to put the grounds here, artificial intelligence is this scientific discipline that deals with creating computer programs that execute operations that are comparable with those performed by the human mind, such as learning or logical reasoning. But the advantage here is that it's much faster. So what is iReviewer? Well, iReviewer is an artificial intelligence tool applied to the natural language analysis that consists of a Jupyter notebook that is implemented in Google Collaboratory, which belongs to Google Research. It allows any user that has a Google account to write and run Python code just into their browser without any programs, external programs. And the good part is that it's free and it's also freely editable. So this is the heading of iReviewer. This is how it looks. It's run just in your web browser, the preferred web browser. So what is it for? iReviewer is capable of analyzing the abstracts of thousands of scientific articles or patents in just a few minutes, returning useful information, and also is capable of determining global and specific themes of the papers, and also group similar articles, and also detect temporal trends in these themes, among other functions. And it also generates freely editable Excel, graphs, tables, and figures. So to make an analogy, we can imagine the whole pool of papers in this library, like an old library full of books, and iReviewer help us selecting what are important for us and the main topics hidden in this huge library that we cannot read. So this is also important. What is not useful for? We developed iReviewer to be impossible to replace the mind of the researcher. iReviewer is just a tool that requires good management by a person and the correct interpretation of the results. We could have gone into this way of letting write for you or give some text generation or something like this, but we didn't want that. We just wanted to analyze the information and give you the data, and then you can decide what to do with it. So we think it's more ethical. We have prepared, Enrique Barrajón has prepared some interactive questions, Socrative questions, so you can
Yes.
access them? Yeah.
Okay, Javi. So we have created some questions to dynamize this speech. So first, I have to ask you to join this quiz by scanning the code that you have in the slide, or also using the link that I'm writing in the chat. This www.socrative.com using the student login. I will now share my screen and check if you are joining. You have to select a nickname and the room that you have in the slide.
Enrique, do you need me to stop sharing the screen? Or is
I
not
don't know.
necessary?
I think that everybody can see my screen, I guess. Can you see my screen with the question?
Yes,
Yeah, okay.
you
So
can see
Okay,
this.
okay, perfect.
Okay, now 5 people have joined. So you can start by answering this question. The first one is only to get an idea of where you came from. That's to break the ice. It's a very simple question that has been created to be sure that everybody is really here and not only a name. Okay, we have people from Kosovo, Hungary, Belgium, Latvia. We have 6 users here, but I think that we are more people in the Zoom. So Turkey, fantastic. Okay. The code, you mean the code FoodWaStop? Okay, the food was stop. Okay, some people is asking about for the code. Okay, can you, Javi? Can you share your screen with the code with the QWERTY?
Yeah, I'm actually sharing my screen.
No, but share it again because there are some people asking for share the BD code to join us.
Okay, I will stop and go again.
Okay. Because some people is not able to join.
Now, maybe?
Okay, now.
Okay.
I give some seconds to scan the code and I return to share my screen to get the questions. Okay. Yeah, as this is not a very important question, I will move ahead to the second one. If you are joining now, you will be able to answer this next one. Okay, so let's move ahead. This is the second question. It's a little bit more specific one, asking for your previous experience of AI tools. AI tools. I also mix the Spanish with the English. Okay. Some experience of no experience is the most frequent word. Okay, during this seminar, we will try to give you some insights and comments to not to become an expert user, but to be able to tool and start creating your own results with this AI reviewer tool. So, Javi, the floor is yours. You can go ahead.
Okay, thank you, Enrique. So we will go ahead and start seeing the next steps. So, what do we need to use AI Reviewer? So it's just 2 things. It's very simple, very straightforward. So first, of course, you need access to AI Reviewer that we will solve it in a minute. And then the second thing you need is an Excel file with the articles or the data to be analyzed. So we will see how to achieve these two goals. So there's a lot of ways to access AI Reviewer. You just have to do it once, because once you have access, you can save it into your own Google Drive or wherever you want. So you can access through this article. That is an article we published a couple of years ago, in which we presented the tool and we validated it. So you can also access to the paper here if we share the presentation, because it's inside the presentation, the PDF. So you can also access, like, Googling cistus antibiotics. Cistus is a plant in which we have been working for around 15 years, something like this. And we are very interested in the bioactivity of this plant. So we used AI Reviewer to analyze all the papers about this plant. And this is the DOI, just in case you have to click it. Okay, so at the end of the article, there's section, the data availability statement, in which this is the direct link to AI Reviewer, to this Google Colab document. And this is the link, so you can just press it in there. So for the second part, how do I get the articles? How do I get this Excel file with the articles to analyze? So you can go to Scopus, and that it's recommended because the format in which the articles are imported fits pretty well with AI Reviewer. So it's just as easy as to go to Scopus and go to search documents, and input your favorite topic, the topic you want to know more about or to summarize the information. And then will be some documents found, hopefully. You have to select all and then click export. When you export, you will get this window in which it says that it's going to be exported as a CSV. And you have to select at least the first and the third column. This is just the information that's going to appear in the document that you are going to download. But you feel free to select everything. The most columns you select, the most information will be in the file and can be analyzed. But the main ones are the first and the third. That includes the more vital information and also the abstract and the text. So we have another question.
Yeah, I will share again the question. Question regarding one of some of the last comments that Javi has told. It's about the information that you have to click, the option that you have to click when downloading the articles from Scopus. Okay, some people in the chat is asking about the language. The question are in English. Maybe during your login process, there are some problems because the tool, the Socrates tool, is in Spanish for me, and as I am sharing my own account, maybe there are some text in Spanish, but you don't have to pay nothing. Just only click, enter the FoodWaStop code and your nickname. Okay, let's check. I have to reinforce that as Javi has told, the columns or the information that you have to click to be sure to be downloaded is the information about the author's year title, which is on the left part of the screen, and the information about the abstract and keywords that will be the text that the AI reviewer will read. So it needs this information just to figure out what the papers are about. Okay, Javi, the floor is yours again.
So thank you, Kike. This is absolutely right. It's absolutely vital that we include the first and the third columns, because we need the informations that are so key as the year, publication, the authors, and also the abstract. And but you can select every column, the fifth, if you want, and you will have more data. If you care about something like sponsors, trade names, manufacturers, etc. So let's move. And here is an example, because I know that it's pretty difficult to imagine how's this useful, how's this for me, for my research. There's a lot of different topics in research. So I'm going to explain a bit what we did with this Cistus research, how it was useful for us, and how was the publication in which we validated it. So maybe it can resonate with something that you are thinking of. So this is the abstract of the paper. I don't want you to read it, just to highlight some things, but it's to reinforce the idea that we are processing the natural language, that is the words, the actual words that are inside the papers. Highlight that we analyzed 1,601 research manuscripts in this paper, and also 136 patents. So in fact, you can analyze every natural language, really, if you have a bit of use of the tool. So the patents were also present in there. So we wanted to know everything that was published about this plant, this cistus plant. And this is something that we couldn't have done manually, because it should have taken so much time to read everything by ourselves in the traditional way. So something that we obtained during this analysis were this type of graphs. In the A one, the left one, this is a graph with the frequency of the words, the most frequent words in these papers, in the whole pool of papers. So as expected, the most common word was cistus, because it was the word that we searched for. And then we obtained something like species, plant, use, studies, extract, Mediterranean, soil, effect, difference, etc. As you can see, as you can note, there are no complete words. In some cases, the word is cut, is truncated, and this is because it merges all the words with the same radix. For example, you have active here, and it includes active, activity, actives, etc. It's just security measure in order to not have a lot of repetition, a lot of redundancy into this analysis. And here in the right, we have the word cloud for all the articles. It's the same information that in this graph, but more visual. The higher the font of the word, the higher the frequency. And here we have 75 words. Meanwhile, we have just 20 here. As we will see later, and this is fully customizable, so you can change everything from the colors to the number of words to everything. So this is one of the strong parts, in my opinion, about the reviewer, that it's the code is completely free, the code is completely open, and you can change it as your convenience. Then we obtained this type of graphs. This is just a part of the silhouette graphs, as we call it, that are silhouette plots that represent the different groups, thematic units inside this big pool of papers. So in this 1,600 papers can be divided into two groups. So the height of the silhouette is about the number of papers, so it should be like 800 and 800 more or less. And then the weight, the more wide, the more similar are between them. So it's like similarity in one hand and number of papers of this group, or clusters as we call it. So this is when we force the program to divide it into two groups or two clusters. Here is 3 clusters, then 4 clusters, 5 clusters, 6 clusters, etc. By default, we run up to 20 clusters, and you can see how they evolve and how they the themes become more specific in the sense that they are narrower, they are shorter. So the number of papers is lower, but they are more similar between them. So you can actually identify specific themes. We will see it in the example. So for this paper, we opted for these 5 clusters because we identified 4 pretty good clusters that were pretty similar among them, and one that was not so interesting, so we just discarded it because it was not about the bioactivity that we were looking for. And also, I forgot to mention that this red line is pretty important because the red line is like the threshold of similarity. If the silhouette trespasses this threshold, we estimate that the cluster is okay. The papers inside the cluster are quite similar between them to compone a thematic unit. So the clusters that are under the threshold are considered not too good.
Just one addition. You can check also that in the second graph that Javi is pointing out right now, the cluster in the middle also moved to the left. Not transpass the red line, but move also to the left. It means that this cluster includes some papers that are not related among them. It's like a kind of merge of a lot of some papers that has no relationship with the other, and that's why some of them move to the left. So the left direction is not good for the final result. We want the more to the left, the more to the right, the better for the result. That's why the class normally in all the divisions, in all the different options, there is always a cluster that contains all these papers that are not related to the rest of them. And that's why almost one of the cluster moved to the left. If you can check it, that for example, this orange that Javi is pointing out is one example of this.
Yeah, thank you, Enrique, because it was really important. And sometimes happens that there's a bit of movement to the left, but this is not representative. This not invalidates the whole cluster. So, and this is what I was telling at first, that this is something you have to interpret and to decide. And you can first decide, okay, I will go ahead with the 7 clusters, and then just see the results and say, okay, I'm not so satisfied, so I will try 5. So you can play, and you can think about. You will see later that we have some real significance behind this clusterization, and you can be the judge to this clusterization. So we also have these pie charts in which the 5 clusters, it's 5 clusters. It's included cluster 0 and cluster 4 because you may know number 0 is key in this programming tool. So we use 0 as the first element on a list. So cluster 0 is the first one. So we obtain cluster number 1 with 489 articles. So was the second in size behind the cluster number 3, and there was a small cluster with just 6% of articles. So very varied distribution. And we selected cluster number 1 as the one that was most interesting for us, as we will see in a moment. We also obtained this PCA, the principal component analysis, in which we can see the relation between the different clusters. So, for example, the number one, that is the one we were interested in, the bioactivity one, is more related, for example, to the green one, to the number 4, than to the number 0, for example. So it's a bit of complex, abstract information that is provided by the program. And so these 5 graphs is the graphs of the frequency of the words that appear in each of the clusters. So for example, we selected the cluster number 1, this one, because it talked about the extracts, the activity, the essential oils, the compounds, the antioxidant properties, the acids, flavonoids, phenols, antimicrobials, etc. It was the themes that we work with. Meanwhile, in the other clusters, for example, cluster 0, it was about more diet, tannins, and goat that they use with animals, etc. The cluster number 2 was about leaf, drought, water stress or hydric stress. Number 3, that was the 4th one. It's about seed, fire, germination, because these 2 species is related to fire and this repopulation after the fires, pyrophytic species. And then the last one was about soil, shrubs, and this kind of more botanical area. So we selected cluster number 1. That was this. Sorry about the quality. Okay, so it's your turn. You're mute. You are mute.
Okay, now, thank you, Javi. A very simple question to be sure that you are following Javi's explanation. It's a question about the figure that I am sharing with you, this one. Which kind of plot is this? You have 4 options. Is the plot that we normally use to select the best number of clusters according the shape of these different colors. Okay, let's wait you to answer. There are 32 people that have joined the test. Only the half of them have answered. So be hurry, please. Okay, let's see how it's going. Most of you have selected the right one. Exactly, it's a silhouette plot, a silhouette figure. It's considered the most important one. And the people that have selected the elbow method is not it's another method to select the perfect number of clusters. But maybe we will show you this kind of charts in following slides. So, okay, Javi, let's go.
Let's continue. And we also have this type of the temporal trends that I said before are reflected in this type of graphs, in which we can see each cluster with a different color, and then from the year 2000, 2000 to 2023, that was the 2022, because it was the last complete year that we had information of the evolution of these themes. For example, we can see the orange that grew a bit in an average. The red continually increased. That the red was the one where we focused on, this bioactivity of the extracts. And then another ones like the pink one was in decadence in the number of publications. So it can be interesting in here about the cistus it was not so different with the evolution, but it depending on the fields, some research that is like very new or very trendy, you can see very high differences between the clusters. So it depends completely on the research topic. And another thing that I think that is very interesting and we can also do and perform with a reviewer is, okay, analyze if there are differences between different type of articles. For example, we were curious about if there were differences between the articles that were most cited and the least cited. So we did two groups. One group that is A and B with the 20% more. Sorry. This was the open access against no open access. So we did the open access in A and B, and not open access, the subscription mode in C and D. So there were 424 articles in open access, and this was the main words, the most frequent words. Here the same, and then against the not open access ones. And we analyzed word per word, and it was mainly the same. There was no such differences in these 20 words, like 19 or 18 were the same. So no really differences between the open access articles and those that are not open access. So pretty interesting. And we also wanted to do the same with the most cited and the not 20% most cited. And we observed exactly the same trend. There were no difference in the themes, but maybe for other topics it's relevant. So this could be a strategy to focus on certain words, certain topics that are most cited if we want to have a biggest impact in the research, or try to know better our topic, our research field, what are the readers most interested in, and other colleagues are citing because they are building on this kind of areas. And another strategy you can follow is that we selected cluster number 1 that had a bit less than 500 articles. We still thought that there were too many to really read and analyze and digest. And then the topic was very broad. It was bioactivity of the extracts of cistus. So we wanted to go to a narrower direction and just focus on the antimicrobial activity of the cistus plants. So we did a subclustering that we call, that is, have this cluster number 1 and make a subclusterization and analyze it again with this tool. So we obtained 12 different clusters with different topics and selected cluster 0. This is all the different clusters all come from the older cluster 1 that was about the bioactivity. So this is different biological activities. And we selected cluster 0 that had the most frequent word extract as we expected. And the second one was antimicrobial. So it was very clear that it was the cluster that grouped all the articles talking about the antimicrobial effect of these plants. And then we downloaded this Excel file from AirViewer that included the number of the article, which was numbered, authors, the title, year, the direct link to the article, and also the abstract. So this was pretty handy because we had the full list of the articles that we wanted to include in our review with the direct link and all the information. So it's a pretty handy way to manage our bibliography that is going into this review or this thesis or this project. So I think it's pretty convenient. Okay, Enrique.
Okay, let's go for the next question. Also very simple if you are following Javi's explanation, because it's a false or true question about the name of this kind of figure. We normally do not include this kind of figures in our papers, but they are very useful for dissemination activity or for the graphical abstract. or if you want to create a poster and so on. It's not a really scientific figure, but can give a very fast view what the topic is about. Because in this example, okay, you will notice that we are talking about rice, bran, cereals in general. So it's also very, very useful. Okay, it's false. It's not a word maze. It's a word cloud. Okay, it was a little bit tricky, but remember, word cloud. Javi, let's go.
Yes, that's a word cloud is a common mislead, so don't worry too much about it. And as Enrique said, this is not very quantitative, even when this is actually quantitative because the higher, the more pixels, the more height of the font, the most frequent, but it's not very quantitative, more qualitative, and it's perfect for posters or more, maybe more directed to not a specialized public. Maybe it's a more visual communication tool. So to summarize what we did in this paper as a quality check for the tool was start for all the articles published about cystus in Scopus, more than 1,600. And then we clusterized it and we selected cluster number 1 with almost 500 articles about bioactivity, specific to bioactivity of this plant. And in the end, we just selected 35 articles about the antibacterial properties of the plant. But I agree with it. Maybe you are thinking, I would have thought the same. Okay, so why we didn't, in the first step, search for antibacterial cystus in Scopus? And this is a very, very, very good question. And this is because we would lose all the information that we gathered in these previous steps. No other tool can help you to see at a glance all the topics about our research, about so many articles. So we had in mind all the global themes and all the information about the global publications of a topic of our interest. And we could break down every topic and see from the inside what are they about and what is more cited, what is more published, what was published a couple of years ago or 10 years ago or 20 years ago. So I think this context and this information is power in the end, and it's really valuable to decide how to move on and how to move on when. Yeah, I think it's very interesting. And now we are going to show another more recent examples. So maybe Enrique wants to share it with you.
Okay.
And I can pass the slides.
Okay,
whenever
as I can share my screen and then
okay.
send it back to you. I think it will be a good idea
Perfect.
to take the commands. Okay, as Javi discussed, telling you this is a more recent example, but a more general one. The example that Javi have used is very specific because it was focused in antimicrobial activity of a simple, specific genus of plants, cystus plants. Here, we started from a very wide topic that was rice straw byproduct or rice straw valorization. So the topic is quite extensive. And that is why we started by 2,700 papers. So this is a very, very big number of papers, as you can see, and we will divide it into 17 clusters. So the number of clusters that we obtained was very huge. Okay, this is the link to the paper. If you're interested, we will share the presentation with you at the end of the session. And this is the results that we have obtained. We decided for 17 clusters, not only this checking this silhouette score or this silhouette plot that Javi has shown you before. The IE reviewer also provides you 2 additional plots that helps you in the process of selecting the perfect number of clusters. One of these plots is the elbow method, that here is showing the number of clusters in this axis and a score in the y-axis. And when you obtain an inflection point like here or here or here, it means that this number of clusters, in this case 18 clusters according to this plot, has obtained a good score, and it suggests you that this can be a good number of clusters for you. This is the elbow method. But the silhouette score plot, this plot on the top, it's really strongly linked to this silhouette plot, because this is the scoring result of this representation. Here, once again, if you obtain a peak or an inflection point, like here, it's very clear, more clear even than in the elbow method plot. This point indicates you that this is a good number of clusters. Then, when you identify the inflection point using this silhouette scoring plot, then you move to check how it looks like the different cluster in this silhouette scoring method. Here, you can see that most of the clusters that are included overpass the scoring red dotted line. So it means that most of the cluster, the majority of the cluster, are very well scored. For sure, there are some cluster that moves to the left, which is, I told you before, is not good. But in this case, it was the best result for our group of papers. These are the words, the most frequent words for each cluster. So as you can see, we have 70 clusters from 0 to 17, but these are the most useful, the most frequent words of each of them. But managing 17 clusters is quite difficult. So once you have checked the list of the words and identify the topics of each single cluster, we strongly recommend you to mix them, obtaining like a kind of groups that cover the topics that are included in different clusters. For example, we group some of the cluster in a contaminants removal group. Other clusters were mixed to be grouped in the biofuels and energy obtention, and so on. Otherwise, it will be very difficult to obtain a good idea of what you are managing in this moment. Just for this is the graphical abstract of the paper, where we try to cover all this topic, because for contaminant removal group, we also then, once we have created this group, we address the different topics or the different themes that are included in this group, like pyrolysis, biochar abstention, and the other ones that were included. And the same with the other topics, with the other groups like biofuels, agriculture, and industrial processes. Now, I'm going to give you another example, even more complicated, because this is one of the results that we are obtaining in our cereal subgroup, where we are trying even to expand our topic, because the previous example was only about rice. But in this case, we were discussing about all the cereals. So we started our search in Scopus by using some keywords like cereals, byproducts, and in the combination, we have created an equation for the general search. And we obtained, if I don't remember bad, 1,700 papers, more or less. According to the elbow method, there are 3 inflection points that could be a good number of clusters. But as I told you before, I prefer to move to the silhouette score, which for me is better. It's more easy to check which are the real peaks. In this case, 11 clusters, 16 clusters were strongly recommended. So at the end, we decided to 11 clusters. Why? In these examples, you can see that 10 of the 11 clusters moves really long to the right. So the number of the cluster that really overpass the scoring red line, this one, is very high. Look, this is specifically, this black, the cluster in black is really specific because it moves a lot to the left, to the right. But in addition, there is a cluster that is really, really bad because the cluster number 3, which is in blue, it's a very bad cluster because it moves totally to the left. Why? Because it contains all the papers that are not related to the rest are included in this one. So now our effort in this serial subgroup is that we are trying to move all the papers included in this cluster number 3 to the rest of the group that we have created in order to really cover all the valorization of cereals by products. This is an example of the other hit point, the 16 cluster. But if you compare this with this, you can see that here there is a lot of groups moving to the right, but here not all the groups move as high as to the right than in the previous plot. Okay, I don't want to bother you. This is the list of the topics, of the most used words for each topic. And now I give the flow to Javi in order to show you how we can customize iReviewer to really give all the information that we need and to be adapted to our requirements. That is probably one of the most important parts of the tool that we have developed. So, Javi, now the floor is yours.
Thank you, Enrique. And as he said, he has all the truth in the world, and this is a matter of the researcher that has to decide which number of clusters to use and which kind of analysis is going to perform. And the context is the key here. Your necessities is the key. Because, for example, if you perform this analysis and you see a high point in this silhouette score graph of 18 groups, but you don't want to be so specific, because the more clusters you do, the narrower are the themes, the more specific they are. Maybe you are more interested in something broader, so you can select a lower number of clusters, even when this is not the optimal for the program. So you have the capacity of choosing and deciding for yourself. Or it can happen that it happened to us in our work group that 20 clusters were not enough because we had many clusters, many papers, sorry, and with a lot of different strategies, and we wanted to really focus on the specific strategies for valorizing variables. So we, instead of doing up to 20 clusters, we did up to 30, and we selected 28 clusters in the end. So a very specific analysis, but it depends on your necessities. So in this part of the presentation, I'm going to show you how you can modify really easily the code of iReviewer to meet your expectation and your necessities. So, for example, for these word frequency charts that we have already seen before, we have this. This is a cell of code, of Python code. I know it can be a bit intimidating if you are not a lot into this coding or these languages, but the only thing you have to really know is that the text that is in green, this number, this 20 in this case, it's for you to change for your convenience. So, for example, if you change this 20 for a 30, instead of 20 words, you will have 30 words, and so on. For the word cloud, is almost the same. If you have this cell, and you can read word cloud equals to blah blah blah, you can change every parameter, including the number of words that it's already by default on 75, but you can change it by the number you prefer. And also you can change another parameters that the font size, the maximum font size, so the most frequent word, instead of 50, it can be 100 or it can be 20. You can just go, click into the number and change it. Also the background color, you can choose like black or red, whatever you prefer. So it's very, very simple to edit it and change it. So for the silhouette graphs, there is a range between 2 and 20. It's not one because it makes no sense to make one group of your papers because it should be the same as it is at the beginning. So the maximum number by default is 20, but you can change it by a 30, for example, as I did in the previous example, and get from 2 to 30 groups. Just as a note, the whole process, if you have around 1,000 articles, 2,000 articles, it takes the program around 5 minutes to analyze everything and to provide all the graphs and data and tables, etc. But if you increase the maximum number of clusters, the time increases with it. So this is the choke point from the program, and it's the most time consuming. So be careful. If you put 50, for example, it's going to take a lot of time, maybe half an hour, 40 minutes, something like this. So I recommend it's more advisable to use lower numbers, up to 20, up to 30. And then if you want to go more into deep, choose one of these clusters or some of these clusters and sub-clusterize, further clusterized. I don't know if I am explaining myself, but we can discuss it later. We also have the PCA, in which we can change things like the colors. This is the color map, C map, and there's some codes in which tab 20 is some palette of colors. We have tab 30, we have accent, and another type of color maps that you can look for color map in Google, in Python, and you will have all the table of the different palettes of colors, black and white, grayscale, all the good stuff. And also the size of the legend, for example, the location of the legend, upper right or bottom left, or whatever you prefer. In the latest versions of iReviewer, we have an interactive PCA because we are slowly modifying and trying to optimize based on the feedback that we receive from the tool and the new advancements on these technologies to improve the program. So in this interactive PCA, you will see that you can navigate through the points. Each point is a paper, and see the title of the paper. So you can really see the relation between the clusters, each one in each color, and the papers inside the cluster. So you can really see how they are interrelated and what are the most close topics on papers. For the pie charts, you can also change colors. You can also modify the title of the plots, or maybe remove the title if you want to add it later or not add it at all. For the specific frequency charts, you can change a lot of parameters, font size, title, number of words. Maybe you want more than 15 words, so you can definitely change it with no problem. And then talking about the thematic evolution, over time, you can change a lot of interesting parameters, like this is the order from by year. You can order it by year or by other category. Year is the most interesting one in this case, and also the starting point. So year is higher than 1999, so starts in 2000, as in the example. And then the order, the size of the legends, etc. There's a lot of different things to change. And this is another addition, latest addition to the program, and it's the same information as the previous graph, but in a different kind of plot, a different graph. This is in percentage of articles of each cluster, depending on the years. It's like the stocks market, right? It's like the evolution over time. Some people prefer it. This graph is pretty good when you have a relatively long number of clusters. For example, for 5 clusters, pretty clear. But if you have 28 clusters, it's going to be a little bit messy. So it depends on the data you have. And then I think this is the last I want to show. This is the Excel table that you can download after you run the AI reviewer. I think this is key. I think it's one of the most important tools that AI reviewer can provide, because you have all the information like gathered in one place, which you have information about every paper for each row, including things that are very interesting, like the cites for each paper. In this case, they are ordered by most cited, DOIs, and the direct links, the affiliation of the authors, the abstract, keywords, a lot of very, very really insightful information. And also the first column is the column category, that is the same as cluster. So all the papers in this example belongs to cluster number 1 in the example. So you can really see all the papers of this thematic unit and what are the most cited ones and what are the groups that are more potent in the field, etc. So I think this is very, very interesting. Okay, so we move to another.
Okay.
Interactive.
The next question is a general question about some of the characteristics of a AI reviewer. So now you have to select the wrong option. It can be used iteratively. You can adapt the tool to your specific requirements. The information about the cluster historical trend is obtained. All word clouds are the only type of plot related to the most common words of each cluster. Great, people is answering. Let's wait some seconds to get almost the half of the answers. Okay. Hey. Yeah, most of you are right. The word clouds are not the only plot that are related, because we also get the bar plot, not only the word cloud, but also a bar plot covering this issue. On the other hand, as Javi has said, you can use the tool to reclusterize and recluster the reclusters and recluster the recluster and repeat as many times as you really need until you get the final group of papers that you are interested in. It also can be adapted to your requirements, the color, the size, the font. So it's very easy. With very few knowledge about Python programming or using the help of Google, it will be very useful, very easy for you. And finally, the last, the option C, we get the information of the historical trend in bars, in column, and also with a line graph. So I think that it's a very good idea of what these are the most important characteristics of AI reviewer. So returning to the presentation, Javi.
Yes, thank you, Enrique. And as he said, nowadays it's simpler really to really modify a reviewer than was a year ago. Because, for example, now, if you are running the program, running a reviewer and doing your own analysis, and there's some error, and Google Colab has an option that says explain this error, and it connects automatically with Gemini. that is the AI from Google, and it tries to explain you why it's failing, and it proposes a solution that you have only to copy and paste into the program. So bit by bit, it's becoming more, I would call, not easier, but most democratic, the use of these programming tools, even if you have no background of programming. So very, very good news for us to use these tools, because Enrique and me, we have not a strong background in programming or computer sciences. We were learning by using them, by very, very interested in this and really pursuing the goal of creating something that can help us to overcome these barriers. So I want to tell you that please don't be intimidated by the code, by all the programming, because it will be very, very easy when you dive into it. And then we have here a survey in which you can go inside, put your questions and your concerns, your examples that you want for us to review, whatever you feel comfortable with, and we will gather all this information and answer you in a following session, and that will take place around the beginning of June. So, and we will also answer you by email if you have some direct questions that doesn't require a lot of explaining on going deep into the program. You can write us with no problem, and we will make our best.
Just before finishing, the last question for today's is a general one, more related with the clustering process. So this question is, you have to select the right answer about which is the sum of the decision that you have to take during the clustering process. The elbow method is always preferred. The higher the number, the better. It will depend on each situation. When you update a list, you will always obtain the same number of clusters. What it means, for example, and I will return to this point later when I see your answers. Okay, fantastic. Most of you have selected that it will depend on each situation. Okay, depending on the cluster, depending your expectations, the what you are waiting to obtain from AI reviewer, you have to select the best number according to you. And regarding the last option, I give you an example. We run AI reviewer for the serial subgroup at the beginning of the year, during January, using 1,600 papers. But at the end, in our last meeting, we decided to update it because half a year has passed, more or less, and we decided to update the information. So we start from the beginning, we run the Scopus, we get 100 more papers. And with this additional 100 papers, the results were totally different because the clusters that we obtain are quite different. So when you update the list of the papers by adding new updates, you will probably get different results because the river is always flowing and you will never go in the same river twice. I don't know if the real translation for English is that, but it's a very old Greek sentence. So I will return to Javi's presentation just to insist that we are here to help you. You can launch your questions using the survey. The survey is also shared. We will share in the chat, but you have also our emails in the presentation in some of the slides, and you are able, feel free to contact us, both Javi and myself. We will try to answer your question because some specific questions will really need a specific answer, and the most general one will be addressed in the second session that we have in the health thinking, thanks to the course action at the beginning of June. I have no more to add. Javi, if you have more to add. If not, Jessica, we strongly thank this chance to share our little bit of knowledge with you and share our tool with all of you in order to promote the use of this kind of tools, open science that will really foster all the people to work and to collaborate. I think that is one of the most important part of the course action, join the people and bringing the new possibilities for the future. So thank you so much, Jessica, Gianfranco, and all the course action staff for this opportunity. And I hope that everybody finds this tool as useful as possible.
Thank you, Enrique. Thank you, Janvier. I personally really enjoyed all the presentation. I am a little bit overwhelmed, but just because I'm not so...
It's the normal feeling, Jessica. It's a normal feeling. Don't worry about that. But when the first time that we created it, and Javi and Fernando, the other people that was working with it, showed me the results. It was like a tsunami. But don't worry, because the tsunami will pass. Okay, you will get wet. For sure you will get wet. But after the tsunami, you really find that it's very easy. It's more easy than it shows, because you don't have to change a lot of things, because the backbone of the Python code is already done. And it's very easy to change very few things to get what you want. It's a question of repeating and using it. That's why we consider that this second session is quite important, because some of you will start using and all the problems will appear. And when you have specific problems, we will be there to help you by email or in the second section. But okay, Enrique or Javi, we have been stuck in this part. We are not able to interpret this silhouette scoring plot and so on. And we will be helping you because we really want to promote the tool in order to start new collaboration. And for sure, you have to cite us. Remember to cite our papers.
Yeah, that's the money to pay back.
Yeah.
Very fair. I would say very fair. Yeah, and thank you for your full availability also in the process that it's coming after this webinar, because now we all were listening and catching all the information. We have a guide that you provide that we will use to try out the tool. And then I believe there will be some question more or less specific coming up. So I'm happy that we already have a planned second session. I see it as a very useful follow-up for the webinar. I don't know if at this point we want to take any quick question from who is following us, or if everything will be left for the survey.
Well, but from my part, I will be glad to take some questions, because I wanted to leave a bit of room at the end, so we have a bit of time.
We have some time. Okay. I'm checking the chat. I see one question from Seba, but Enrique already answered. Okay.
Yeah, hi everyone.
Hi.
I ask a question. You use AI tools to evaluate the big data, and you made AI evaluation. So this type of journals can be named as research papers, or can we name them as review or research paper?
No. We consider that the use of tools like this are totally fair. I mean, if you are not using or you don't want to use this, okay, you start a review by clicking some keywords in Scopus, download of the list, and then, okay, this is a lot of number of papers. I will not be able to read all of them. Okay, let's change the keywords. Okay, human, diabetes, last 10 years, and you are creating some bias in your review. But with using this, you don't eliminate or include any bias because all the information will be available and it will be included in the analysis. You are using this tool to cluster the information. And then you have to, in the methods of your review, you have to explain, okay, I have used this tool, which is totally free and editable in this link. It's an open source tool. And this is how it works. I started by clicking or performing this search in Scopus using these keywords. I get 2,000 papers. Then I clusterize in this way. These are the results because you can share all the results as supplementary information in a non-editable form, just to be sure that no one changed your results, but you can share. It's open science at glance. So it's not a question that you are substituting the humans for AI. As Javi said, AI reviewer is not created to change humans for machines. It's created to help us to really manage a huge amount of information because nowadays we have a lot of information available. Because
you are screening the information.
Yes, for example, one of the in my opinion, one of the drawbacks or the limitation of the reviews is that most of them do not include patents because there is not easy way to get the information for the patent. But you can include all the patents using AI reviewer because AI reviewer is able to read the patents. So it's very easy. And it's very useful. And if you are fair and you describe what you have done in your methods of your review, it's totally fair, in my opinion.
Thank you very much. Gracias.
You're welcome. Go ahead, Laszlo. Nice to see you.
Nice to see you. Thank you, Enrique and Javier. You just mentioned patents.
Yeah.
And when I add keywords and I download the abstract or upload to AI reviewer, does it include the patents or should I access a different database for that? It was not
you have in Scopus there are no availability of patents, but for example, SpaceNet and some other databases about patents, you can download the information in the same way that using Scopus. Or if you are not able to find, you can include manually in the Excel file that you download from Scopus, you can enter all the documents, patents, books, and all the information that you want. You can add additional lines that will be analyzed by a reviewer, including patents, including wherever you want. The problem with patents is that it's not really an open source because for you, if you are interested in download all the information about, I don't know, diabetes from Scopus, you can download 10,000 papers, but you cannot download 10,000 patents from nowhere because there is not a really open database for patents. At the beginning of our study, when we published the first paper about cistus research, SpaceNet, I will write down, or in the SpaceNet is the name of the SpaceNet. This is you were able to download the Excel file of all the patents for a specific topic. But after the publication, more or less, Javier, correct me if I am wrong, couple of months after the publication, this opportunity disappeared from SpaceNet. You are not able to download the Excel file with all the patents for a single topic. Why? I don't know. At the end of the day, patents are not as open as publications. There are some economic interest behind the patents. It's not fully available. You have to get a lot of effort to really get all the information from patents.
Okay, thank you. Thanks.
Any questions? Don't be shy. And if not, remember that you have the survey to contact us.
Actually, I have one question, but I couldn't find the point. So may I ask one thing? So we have doing some clusters after entering these specific keywords according to our research area. Then after doing these clusters, we have been collecting a lot of, for example, thousands or at least hundreds of papers. Do we have any opportunity to get some summary of the abstracts?
This will be the second version of IO reviewers. This is how now our mind that we are looking for creating some additional tool. Like, okay, now these are the papers. I want an abstract.
Yes.
But we are. I don't want to spoil it myself, but we have submitted a new paper with another tool that is able to do that. Because so we are in that way, because at the end we have the same question that you. Okay, I will get a lot of papers, but I don't want to read. Give me an abstract, please.
Yeah, maybe it can give. Of course, I do not mean that I should write the articles instead of us, as you mentioned.
No.
It's not a substitute of the human or human brain, but it can help. It can summarize the main content, because think about that. We have produced 20 different clusters and with hundreds of papers. It's hard to read all of them. Of course, finally, we should generate content, but we need some more helpful, points. So, Enrique, we will follow your paper to be published.
Okay. Let's wait, because fingers crossed, because we are very expecting the answer in the following weeks, because it's under revision since more or less twice a week. So let's see what happens. But at the end of following your comments, Fernando, our sensei, Fernando, which has taught all that we have now about artificial intelligence, he always said that artificial intelligence is not clever. It's very full. It's fast, but not clever. We should be clever, or cleverer than the artificial intelligence, because we have to select the right cluster, the right number of papers, the right keywords to start with, and this is our task, not the task of the AI. At the end, it will be helping us, as you said, Osgood, to manage a lot of information, but we should be the final user of this information and convert in a paper, in an abstract, or wherever we want. For sure, artificial intelligence will be supporting us, but we should be the most important part of the work. For sure.
In that regard, it's completely true that AI nowadays is very fast, but it lacks a critical point, that it's this critical capacity is not critical. So you can check it if you use another AI tools like ChatGPT, something like this. It always tries to give you the reason and tell you, oh, you are so clever, you are so intelligent, you are have the truth. So we cannot permit this into a tool that creates papers, because it could be completely lackluster. So we retain this capacity to be critical and to analyze all the information, and we are responsible for what we publish. So it's a very thin barrier and a very thin line, and we want to keep the ethics. So in the new tool, we will have an easier time like reading these abstracts, but it will not write the paper for you. So we keep it ethical, and we don't want to replace us by robots for now. And another thing I want to add before I forget is that the times that we give this type of courses, people see this as very far from their topics, and is when they try it and they look at the program and they use it for their own research, is when they find the value. So I want to encourage you to take a bit of time when you are able and try to use the tool with an example that you are comfortable with your own topic, because this is the best way to judge if it's useful or not. And it's not also useful for reviews. It is for analyzing the state of the art of a project, a thesis, a final degree thesis. It's useful for a lot of things, that maybe even for things that we haven't thought of for now. So that was just that. We have another question, I think.
Hello. Hello, everybody.
Hello.
Enrique. How are you?
Hello. Fine,
Thank you.
thanks.
Sorry,
Nice to see you again.
Thank you. I wasn't with you from the beginning of the because I have classes, so I just joined in the final 30 minutes. But I could understand a little bit at the end what is the purpose of this seminary, and I think it's a very nice thing. And we have already discussed during our meeting in Cordoba. But I have a question. It means that this is like a machine learning, development of machine learning, or in this case, I think that it's good because you use the database from Scopus. So the data, we can say that the data is good. But in the case that you want to use that for other database, imagine that you want to, for example, in my teamwork, we work on drug discovery and or in active compounds. So we are looking for active compounds from different plants, from different areas with different focus on activity. So do you think that I'm sure that the origin of the database is very important? Do you think that it's that this work we can expand to all this kind of activities? This is my first question. The second one is that about proteins. Do you think that, for example, for identification of structure, for example, if you can, sometimes we want to do some review about proteins, or about chemical structure, or about insecticides. So do you think that it can be expanded, for example, if you design the most structure of one compound, and then you can have some derivative from this compound with this methodology? Thank you very much.
Okay, may I, Javi?
Yeah, of course.
Okay, the answer is more or less yes. Okay, you can adapt AI reviewer to the data that you want to study, because you only need an Excel files with different columns with information that you need.
Okay.
AI reviewers will read the information and find which are the common words between the different papers or queries or proteins or molecules, and will group them in different clusters according to the most repeated words. So the source, the original source where you take all the data is not important, because you can adapt the Python code for the specific Excel file that you want to use. Okay. Nowadays, this version of AI reviewer is designed for papers. But for example, if you are looking for information about protein, you can go to Scopus, include the name of the protein that you are interested in, 3D structure, and you will get all the papers. Then launch the AI reviewer against this list of papers, and you will be obtaining all the information, the plot, without any change. But if you want to go ahead and modify the Excel file, including specific information for specific molecules or the use of another database, okay, can be, the Python code is fully free, and you can download it and modify as you want with our support or not, because okay, we will try, we will help.
Of course, with your, yes, of course, yeah. This is the purpose. The objective of this, of the cost action, is the networking, and I think that we have already discussed about this, and we are working on that way. Thank you very much.
Have I understood? Have I answered your question?
Yeah, perfectly. I will send you an email to to discuss some collaboration. Okay.
Okay, fantastic.
Okay. Thank you
So
very much. Thank
just
you.
as an insight, just for you to know how really a reviewer works, it can analyze anything that has words. So because it analyzes language. And we have highlighted the process in which you go to Scopus and you download the Excel and you analyze it. But this is just because we designed the code, the Python code, to recognize the columns that are in the Excel file that you download directly from Scopus. But
Yeah.
it could analyze whatever structure that you want. But you will need to go to a reviewer and tell, okay, so my Excel file, instead of having the columns named title, abstract, year, and sites, have these other columns that are molecule, structure, and activity. So just changing that, the reviewer tool can analyze anything that has text. So it doesn't necessarily have to be papers from Scopus. You can analyze whatever text that you have in mind, but you have to keep in mind that you have to change something. But that's it.
Very good. So congratulations to both of you, Enrique and Francisco Javier, for opening this new window on something that I think for most of us was unknown. So it was great. And please, all the participants, take notes that on 3 June at the same time, so 4 p.m. or whatever is in your country, we will meet again for the second session. So we appreciated a lot of discussion. And you brought the ice basically of the webinars. So we hope to have a pretty long list with the whole working group. Just for your information, after the 3 June, it will be a next webinar on writing and on index. I will place just on the, no. I will place the link here into the chat. So it will be an expert of Springer to tell us about the tricks or the instructions to write a good paper. And one of the item of cost action is to write good papers, hopefully taking together people from different nationalities. As well, in some working group, already some papers were published or are in progress. So I'm very happy how it is progressing, the action and the interaction. So with, as I told you earlier, with some of you, we will be in Thessaloniki for the training school that the working group 1 and 2 organized very well. Last of things, take also the survey, take the survey, click for the survey and try to answer at best. Last but not least, I'm sure that all of you joined the survey on food waste, and we had more or less 1,000 answers. But just in case some of you did not yet do, we are summarizing the data, and it will be great to have a wide coverage. And and it is a way to rethink our daily behavior, because we do small things, but if we take one drop each one, we will try to change a little bit and shape our future. So thanks you all, and let's see at the beginning of June or early with some of you in Thessaloniki. Have a good afternoon, evening, and see you next time. Bye to all of you.
Thank you.
And no, please show up, everybody, with the camera if you can. Yeah, there is a funny
Final photo.
Fox. Oh, Barbara, that's very nice. The fox. Okay. Here we are. You all in? Wow. 1, 2, 3, 4. Okay, Quang. Okay, are you in? Okay. Very good. 1, 2, 3. Everybody's in. Now is the time to see if the people are actually in or just opened. So, okay. Thanks you all. 1, 2, 3.
Okay, bye-bye. Thank you.
Bye. Thank you.
Thank you, Enrique.